Hey guys, so I'm making this video because the Unreal docs didn't work. I faced a lot of error whenever I was trying to set everything according to the Unreal docs by using a custom character and a custom animation. Also, I wasn't able to find a video where everything was explained, where you can create a custom character with custom animation using C++. So I decided to make a video of my own so that it can help others out and they won't have to spend hours on it. Also, if you guys have any doubts related to this video, then you can always contact me on Discord or Twitch. I'll be mostly streaming on Twitch, so you can find me there. With that, let's get into the video. With that, let's get ourselves a character from Mixamo with T-pose. Then I'm gonna get both a single jump cycle and also a split jump cycle to show you why it's better to use the split jump cycle. One important thing to note is that only this T-pose should have skin when you export. That is, the animations that we will export later on, like run and jump, we will export them without any skin. Because when we import the T-pose, we will have the mesh and we will use that mesh as the skeleton for the rest of the animation. Also, don't forget to set the animation to in place, else it will move away from the spot. To split the jump cycle into 3 parts, use the trim option over here and split to 3 parts like jump start, in air and landing. Once you downloaded the animations, you can import them into Unreal. First, import the T-pose as it has a mesh along with skeleton. And if you're confused because I said mesh, I meant skin. Going forward, I might switch between the two, but both means the same thing. When importing the T-pose, make sure the skeleton is empty, as Unreal will create one for you. Ignore the smooth mesh warning and import the animations now. For the animations, you can select all of them and drag and drop them. It's similar to importing the T-pose, but here you have to select the skeleton, which is the T-pose skeleton that we imported before. With that, we have our animations ready and first step is over. Moving on to the second step, let's set up the input keys we will use for our character, which are WASD for movement, mouse for looking, space for jump, and shift for sprinting. Action mapping is where we add keys which perform actions like jump and sprint. As for movement and looking, we use axis mapping. In the action mapping, press the plus icon to create the first action. Remember the name you enter over here, as we will be using that later on to call the input. Now add the button for the action you created, which is spacebar for jump. Click on the drop down and type spacebar to search for it. Once you find it, select it, and with that we have the first input. Do the next one by yourself by creating an action mapping called sprint for creating a sprint action with shift as the input button. Now moving on to the next step, which is axis mapping. Set the scale for W to 1 and S to -1 to represent forward and backward movement. Same with A and D, set one of them to 1 and the other to -1 to move left and right. I would recommend to change them to the opposite value and see what happens so that you will get a better understanding. Now for the mouse movement, there's two type of movement. Looking horizontally, which is left and right, then looking up and down. For looking left and right, set the mouse x-axis scale to 1. As for the up and down, set mouse y-axis scale to -1. With that, our inputs have been set. Now let's set up the character controller using C++. Back in the editor, go to the tools and select a new class. Choose the character as parent class, and after giving a class name, press the create class to generate the class files. Once the class is created, the code editor will be open with your header and class files. Now let's follow the steps explained in the docs and create a character class. Declare a spring arm component and a camera component which will follow the character in the header files. Add the following class libraries to the CPP files and declare them in the constructor. Now set the location and rotation of the character mesh component so that it will face the correct direction and the camera and spring arm component will be behind it. Now attach the spring arm and camera component to the skeletal mesh. Set the class variables for spring arm and movement components and compile the code to see what we did. In order to see what we did, right click on the C++ character class that we created and select create BP class. This will create a blueprint class based on our C++ character class. When we open the blueprint, we can see the camera and spring arm component that we created in our C++ class file. Now let's move on to the next step, that is giving movement to our character. In order to add movement, declare the functions inside the class. These functions represents the move forward, move right, begin sprint and end sprint. As the name says, move forward is to move the characters forward and backward, move right is to move them left and right, whereas begin sprint will start the sprint and end sprint will stop sprinting. Now we have to go back to the CPP files and implement the logic for the methods that we have declared. Declare the logic for the first function, which is move forward. The controller inherits from a character class which has built-in movement logic, and it is saved into the rotation. The yaw rotation takes the value from the rotation's yaw, which we declared in the last line. Now we find the direction by checking the axis of the yaw rotation. Here we'll be taking the x-axis and we'll save it to the direction. Now for movement right, we perform the same step except instead of x-axis we'll be using y-axis. Declare the begin and end sprint methods and get character movement and add a max walk speed of 1000 for begin sprint and 600 for end sprint. So when you press shift, the speed will be increased to 1000 and character will start sprinting. Now add the player input component over here. The forward, right, turn are the input names that we declared before, and this is where we'll call it. Now compile the code and let's see what happens. The next step now is to add a game mode class. So similar to how we created a character class, create a game mode class and then create a game mode blueprint of that class. Similar to how we made the character blueprint. Open the game mode blueprint and add the character BP we created as the default spawn class. Now go to project settings, maps and modes and set the default game mode base to the one we just created, which is game mode BP. Now open the character BP and select the mesh, which is the T-pose that we imported in the beginning. Now compile everything and press play. There is an issue right now which you might have noticed or might not have, but before solving that, let's move on to the next step, which is animation. Adding walk and jump cycles to the character we created. For this, we'll be using animation blueprints where we control all the animation that happens. So right click and create an animation blueprint and open the blueprint. In the animation graph, right click and search for state machine. Select it and give it a name. I'll be calling it locomotion. Connect the node to the output pose and double click the state machine that we created. Create another state by dragging the entry and call the state idle/run. Now let's go back to the editor and we'll create a blend space. A blend space allows us to blend the different animations such that you'll be able to transition from idle to walk to running smoothly. Right click animation and then blend space. Give a name and open it. In the horizontal axis, give the name speed and give it a maximum value. The horizontal and vertical axis represent the graph below. Because we gave the sprint speed as 1000, set the maximum axis value for the speed as 1000. Drag and drop the running animation that you imported before them from Mixamo at 1000 and the idle animation at 0. Now if you hold control and just drag the mouse over the graph, you can see the transition happening. Now if you guys remember, we did have a minimum value of 600 from where the run starts. So in Mixamo, you can get the walk animation and add that at the 600 position in the graph. That way the transition will be even smoother. Now I haven't done this, but you can do this by yourself so that you'll get a better understanding. Now we'll go to the event graph. Here we will create two variables, a boolean and a float. Name the boolean variable isGem and the float variable as speed. Take the return value and cast it to my character BP, which is the character blueprint we created. The event update will update the animation as we press the buttons like shift or W, that is the input that we give. Now we need to know the speed at which we travel. We gave the value as 1000 before. So to get that speed value from the character BP, we use get velocity and attach it to a vector length and attach it to the speed variable that we created. With this, the idle/run animation will get triggered based on the speed. Don't forget to attach the character node to the speed. Now let's go back to the locomotion state and enter the idle run state to set the blend space animation that we made. Inside the idle/run state, drag and drop the run idle animation, which is the blend space that we created before. It will have a speed as entry where we will attach the speed variable we created before. And if you're wondering what the speed entry in the node represents, it is the horizontal value that we gave. I hope now the working is clear. The speed value from event graph will trigger this animation when it hits the speed, that is 1000. Else it will show idle. For that, press compile and you will see the idle animation. Now to show this animation when you press play, Go back to character blueprint and go to the animation mode where it says use animation blueprint. Under that, there is an animation class. Inside the drop-down, find the animation blueprint that we created for this project. Now compile everything and press play and it should be working. You might have noticed a small issue, which is what we left off in the beginning. That is, the mesh won't rotate to the direction you press. To solve this, add these lines of code to disable the pawn control of the base class and leave that control to our logic which we created. Now if you compile the code, the character will rotate and move to the direction you press. Now let's set up the gem. If you follow the method displayed in the docs using single animation gem, this is what happens. The gem won't match the animation cycle. In order to solve it, we will use the split animation that we used before. Now these methods are from other channels and resources. I'll list all the resources I used below so that you can check them out, and if you still have doubts you can reach out to me on Twitch or Discord. Alright, so back to topic. Let's go back to the animation blueprint. Drag off the node from idle, running, and create 3 other states. First one will be the initial gem, the second one will be in air, and the third state will be called landing. And then connect that node back to the idle running so that a whole loop is created. Now go inside the initial gem, attach the one which shows as if you're jumping up. For me it was jumping 2, so I used that as initial state. For the second state I used gem 3 animation as that looked as if the character was in air. Now for the third one I used jump 1 as it looked as if the character landed. But because the animation ends, it has to transition to idle running, and so along with the jump animation we will add the blend space we created before the idle/run. Attach the speed variable to the entry like before. Now right click and search for layered blend per bond and connect idle and ending jump animation to the node. Select that layered blend per bond node and go to the layer setup and add an array element. Now go to the skeleton section and select the bond here and copy bond name and paste it over here. This is the transition state and also the entry for the jump animation. Now connect the boolean isJump variable which we created before to the middle of initial jump and idle running state. If you don't know what a boolean is, it checks to see if a condition is true or false. Here we check if the user presses spacebar. If so, the boolean will turn true and the character will jump. That is the whole concept of why we are using isJump boolean over here. In the next middle section between initial jump and in air, right click on the graph, search for time remaining ratio node and attach a less than node with second value 0.1 and connect it to the result. For the third one, just add a boolean node in between. And for the last, similar to second one, create a time remaining ratio node and attach it to the result with less than 0.1 and compile the code. Now we need to set the isJump event. So for that, let's go back to the animation blueprints event graph. Now drag from the character blueprint node and search for get movement component of the character blueprint. Drag the node out from character blueprint and search for isFalling node and connect that to the isJump boolean that we created. What happens is it checks for the character movement from our blueprint and checks if the character is falling. And if the character is falling, the boolean isJump will turn true, triggering the jump animation. Now make sure you have compiled everything and then press play. With that, we finally have a third person character which can run, walk and jump around. With that, I hope this video helps you guys out and hopefully you guys didn't face any issues. If you did, as I said before, you guys can contact me on Discord or Twitch. With that, I'll see you guys in the next video. Take care. Have a great day.